All right, so Unit 12, excuse me, for chemistry is solutions. We're actually going to do solutions again. So this is I've labeled it as part one. I'm very creative. And so these are kind of the basics. And we're going to start with some conditions, kind of what you see with how solutions are formed. And then we're going to end with a little bit of math and calculating concentration. So you're welcome. Okay, so solutions, remember, are typically described as homogeneous mixtures, which means that to the eye they look all the same, but that they do not necessarily have a uniform, not uniform, that's the wrong word, a set, like a recipe. So they can combine it in different amounts. Typically, we deal with aqueous solutions, and that just means that water is the solvent. And in case you forgot, remember that the solvent is the substance that is doing the dissolving, and the solute is the substance that is being dissolved. And the whole process is called solvation. And so this is where you have a solution being formed. Just as a review, down here at the bottom, what is the difference between homogeneous and heterogeneous mixtures? I kind of said it already, but remember, with homogeneous mixtures, visually everything looks the same. With heterogeneous mixtures, you can see the different components very clearly. Okay, so making the solution. So first off, there are three factors that affect how fast something dissolves. Heat, particularly heating the solvent, stirring or agitating the solute and the solvent together, and then crushing or grinding the solute. You do these three things typically when you make hot chocolate, which is why I have that on there. But you heat up your milk, you dump in the cocoa powder, the hot chocolate mix, and stir it. And then a lot of times, you know how you have like the little chunks of powder that just won't mix in, and you'll take your spoon and kind of, like smush them up against the side of your cup. You do all three of those things when you're making hot chocolate, and they just make it happen faster. Now, solubility deals with how much of a substance will dissolve in something else. And so, how easily does the solution form, or will the substance dissolve, and how much? And there are three factors, and that's what we'll spend most of the rest of this video on. Three factors that affect if a substance will dissolve and how much: temperature, pressure, and that one will only apply to gases, and then the nature of the solute and the solvent, so the nature of the two things that you're trying to dissolve together. Okay, so temperature. First off, some terms that have to do with temperature. You have an unsaturated solution if you could put more solute into the solution and have it dissolve. So for example, if I have a glass of tea and I put half a teaspoon of sugar in there, so a tiny bit of sugar, it's a good nice sized glass of tea, it's unsaturated because I could put more sugar in and stir it up and get it to dissolve. All right, saturated. Saturated is a solution that cannot dissolve more solute at a given temperature. So if I take my glass of tea and I, dump in 3 more heaping tablespoons of sugar, which is what it would take for me to drink tea, because gross. And that sugar started to settle to the bottom, then the solution itself would be saturated. It can't dissolve anymore, so that's why the sugar starts to settle to the bottom. Then supersaturated is where you have a solution that contains more solute than usual at a given temperature. So say I take my glass of tea with a whole bunch of sugar, sitting at the bottom, and I put it in the microwave and I heat it up until it's pretty warm, and I stir it, and the sugar all dissolves, and then I let it cool back down to room temperature. That is a supersaturated solution at that point. This is how they make things like rock candy. peanut brittle, fudge, all of those are super saturated because you heat it up to get, in all three of those cases, sugar to dissolve, and then you cool it back down and it stays dissolved. Okay, so now temperature. So the first thing that affects if a solid, or if a solution will form, is temperature. So if we're talking about solids dissolving into liquids, as you increase the temperature, most solids increase in solubility. Excuse me. I mean, there are some exceptions, of course, to that statement, but for the most part, if you take a solid and you put it in water and you add some heat, it forms a solution. And typically, the more you increase the temperature, the more substance or more solute you can get to dissolve. So my little question over there, what type of relationship is this? If I increase the temperature, then I increase the number of grams that can dissolve. That would be a direct relationship. Okay, now more with temperature. If you're trying to dissolve gases into liquids, it is going to be the opposite. As you increase the temperature, gas solubility decreases. And so my graph, a little off there, but basically you have this downward curve. And so why? And this is based on the kinetic theory. If you give gases more energy because you're giving them more heat, you're raising the temperature, you are giving them just more of an ability to move fast and to escape the liquid. That's why warm Cokes are flat, because the gases have escaped from the liquid. Okay, a little bit more on temperature. This is not necessarily making the solution, but kind of as a result of making a solution. For acids and bases in water, and typically with even a gas, or adding an acid or a base in water, you get the solution, but they will almost always, again, not 100% of the time, release heat. And so in the beaker, like you're holding them in your hands, you put them there, they will feel warmer, or the beaker will feel warmer. And so when heat is released, and it's maybe been a while since we've talked about exo and endothermic, but if heat is released, it is exothermic. Okay, pressure. Now this only applies to gases. And so again, it only applies to gases because they are very, very susceptible, like we talked about in the gases, to changes in pressure. I can compress a gas by putting more pressure on it. With pressure, gas solubility, and gas solubility only, is directly related to the pressure of the gas above the liquid. This is based on Henry's law. It looks like a gas law because it is. And so the S is solubility, the P is pressure. We're not going to work any problems with this, but I did want you to see the direct relationship represented mathematically. An example of this is the little, when you have a bottle of Coke, and when you first open it, you hear the release of the gas, release of the pressure. When they bottle them, they put extra gas in that space in order to keep the gas dissolved in the liquid. As soon as you open that Coke, you'll notice bubbles rising in the Coke itself, in the solution, because now the pressure is not on them and their solubility drops. Like they now have a way to escape. Okay, last thing that affects if a solution will form is the nature of the solute and the solvent. And the general rule of thumb is that like dissolves like. And by that I mean that substances that have the same polarity or like polarities dissolve in each other. So something that is polar can dissolve something else that is polar, or something that is nonpolar can dissolve something that is nonpolar. It is the reason that oil and water don't mix. Oil is nonpolar, water is polar. So that's the reason they don't form a solution. So my little equation there, NaCl is just salt. It is polar. Water is polar. And salt dissolves very easily in water because of their like polarities. Okay, so now to the math. Calculating concentration. Concentration is the amount of solute dissolved in a given amount of solvent. So if you're talking about a dilute solution, you typically have, and we'll write this in class, but you typically have a low amount of solute and a larger amount of solvent. Like they're kind of opposites of each other, or one solute is low, solvent is high. Concentrated solution is the other way around. You have an increased amount of solute and a lower amount of solvent. Dilute solutions are made by adding more solvent. Concentrated solutions are made by adding more solute. That's, again, I think kind of common sense. We'll talk about it more, but kind of, use kind of common examples. Like if you've ever had like really weak Kool-Aid because you didn't put very much of the powder in there with too much water. And if you want to make it more concentrated, you dump more Kool-Aid powder in there. Okay, now calculating concentration. There's several different ways to calculate concentration. Probably the most common is molarity. Molarity is the number of moles of solute dissolved in 1 liter of solution, or in liters of solution. The formula for molarity, is moles of solute over liters of solution. So, of course, we have an example. Okay, so what is the molarity of 2 moles of glucose added to enough water to make 5 liters of solution? So we just said molarity is moles over liters. So I have 2 moles and I have 5 liters. So 2 divided by 5 is 0.4, and the unit for molarity is capital M. They can be a few more steps to this. If I had given you grams of glucose, you would have to convert it to moles. If I had given you milliliters, you would convert it to liters. We've done all of that. It's just kind of, putting it all together. Okay, a second unit of concentration, and I'm not the one who made this up, so don't blame the messenger here. Sounds very similar to molarity, and it is molality. Molality is the number of moles of solute dissolved in kilograms of water. Kilograms. And so, formula, moles of solute over kilograms of water. And so this one I made a little bit tougher so you can see some of the extra steps. So it wants to know what is the molarity of a solution that contains 15 grams of KCl dissolved in 200 grams of water. And so first thing you have to do is get to moles. So you would do 15 grams of KCl and a mole problem, 1 mole. And then KCl, so 39 plus 34 is 35, sorry. 39 plus 75, yikes, start that over again. 39 plus 35 is 74. Oh my goodness, that was way tough. So then 15 divided by 74, let me check on my little cheat sheet here, is 0.202, something like that. And then that's moles. And then you would say, let's see, you've got 200 grams of water, so you would have 0.2 kilograms. Okay, remember, moving your decimal 3 places gets you from grams to kilograms. So you move your decimal, and so essentially you would end up with 1, and the unit for this one is little m. I know, it's confusing, I'm so sorry. But, so pretty straightforward problems. Again, though, you just have to make sure that what you have, you can convert it into what you need. And that's why we did moles last semester. That's why we're at this point now. Okay, so now, what if you have to kind of work it backwards? What if you know what the molarity or the molality is, and you want to know how many grams are needed to make a solution? This is much more common. Back in my glory days of washing dishes and making solutions for people, I did a lot of this. You know, they would say, okay, Kimberly, we need 300 milliliters of a 0.5 molar solution of Ki. So I would have to figure out how many grams to weigh out, how many, you know, grams to put in the beaker before I added the water to make 300 milliliters of solution. So to do this one, you set it up backwards. So you have 0.5 equals, and then I've got 300 milliliters. Remember, that's 0.3 liters. And what I don't have is anything related to moles or grams. So that's what I have to find. So then I know that X is going to be, let's see, 0.15 moles. And this is moles of Ki. So then to get something actually, you know, measurable, I have to go to grams. This is 1 mole. All right, and so then, again, I looked ahead, trying to be better here. Let's see, K is 39 and iodine is 127. So if I added those correctly earlier, that's 166. So 0.15 times 66 gives me 24.9. So I would go to the scale with my bottle of Ki. I'd measure out 24.9 grams. I'd put that in a beaker, and then I would add enough water to make 300 milliliters of that solution. Okay, so now some other types of concentration, and I don't have example problems of these, but we will do some in class. Sometimes solutions are measured in percent volume, which is the volume of the solute over the total volume of the solution. Sometimes they're measured in percent mass volume, grams of the solute over milliliters of the solution. And sometimes they're percent mass, grams of the solute over grams of solution. The big thing to be aware of on all of these is that we're talking about solution. Sometimes they'll give you the solute and the solvent, and you have to remember that those two things together, so those two things added, make up the solution. Okay, almost finished here. All right, so then sometimes you also make solutions from other solutions, basically by dilution. The thing to remember in this is that the number of moles doesn't change. So even if I add more water to something, I still have the same number of moles in there. So the moles before the dilution are equal to the moles after the dilution. And if you remember, molarity equals moles over liters, so here's that. So then I can kind of reverse that up and have molarity times the volume of the solution, or liters of the solution, are equal on either side, before dilution and after dilution. And so if you do all that and you then need to determine the amount of grams, that's when you have to go to the periodic table and solve, just kind of like we did on the page before. Okay, last little page is an example again. So this is the dilution problem. How many milliliters would you need to prepare 100 milliliters of 0.4 molar magnesium sulfate from a stock solution of 2 molar magnesium sulfate? So notice this number is bigger than this number, okay? So it is more concentrated. So I'm basically wanting to dilute a small amount of the concentrated to make my new solution. And so my formula is the M1V1 equals M2V2. So I want 0.4 molar. I want 100 milliliters. Doesn't matter that it's milliliters or liters as long as your units are the same. So I'm going to find milliliters, but I know that I'm working with 2 molar, and what I don't know is how much I need of that. So I have 40 equals 2x, which means x equals 20. So what this is telling me is I'm going to need 20 milliliters of that 2 molar MgSO4. So basically I'm taking concentrated a small amount and I'm diluting it. The other thing that you always need to do is tell me how much water you would add. So if I need 100 total milliliters, 20 of it is the concentrated solution, and then I'm going to add 80 milliliters of water to get the whole thing, because 20 plus 80 equals 100. Okay. Again, stop and think about this, you guys. I mean, these are things that you do without even thinking about. Like if your Kool-Aid is too strong, I mean, can Kool-Aid ever be too strong? But if your Kool-Aid is too strong, then you add water to it, you dilute it, and that's all that this problem is telling you. Just put some numbers with it. Okay, that is what Unit 12, Chemistry. We will of course go over all of it in class. Be there and ask me questions. Goodbye.